Okay, so looking ahead, you should have finished this assignment, Bouncing Ball with Objects. It's rewriting your code from assignment 13, Bouncing Ball without objects. Assignment 15 is mostly the Pong assignment where you get the paddle going. That's what I'll demonstrate today. You could extend it more to like keeping score, to having 2-player Pong on the screen, 4-player Pong, Beano's Pong, yes, all those good things. There's room for that, and it's due May 8th, tentatively. That's the earliest it will be due, but I think some of you might be able to finish by week's end, and in which case try some of the extensions. And then our last assignment is Brick Breaker, so building on top of Pong. You've seen Breakout before. You have a ball that bounces around, you have like a wall of paddles, and then they disappear. It is part of your assignment to play those games, so go ahead and try them out. So this is part 3. We're trying to get this rectangle going, and that's what I'll try to demo today. So this paddle logic, though, does get kind of complicated, and I don't think I have many videos from last time that I taught it. I do have one useful picture of the whiteboard, okay? I'd like to draw this out in class. So if you stare at this and you translate this kind of stuff into JavaScript, right, into CodePen, then it should work. But it'll take some deciphering, and I'll probably explain that come next lecture. I figured that for this demo that we will add on to what we had previously of an object, and all it does right now is it moves across the screen, starts in the middle and goes right. We'll first make it bounce off the right wall, which you all should know how to do at this point, some if statements. And then we're going to add a paddle, not so much on the left wall, like not touching it, because if it's too close to the left wall, we won't know whether or not it bounces off like the left wall boundary or my like paddle boundary. So we're going to have it a little bit away from that edge to confirm that, oh, my ball isn't going through my paddle. Okay, and it'll just be one-dimensional bouncing. It goes left and right. So over here, we've defined the very minimum of a ball class, right? Using the class keyword, it has an x coordinate, so we've listed it here. It has a show method, which gives it its structure, puts it onto the screen, it draws it. The move function, we can see that it moves right. Then down here, we created a ball. This middle one is Bob, great. And then let x equals 200. This was to demonstrate that the first time that I drew it using a variable x, that was different than the x that belongs to the ball class. A student raised this question in one of my YouTube videos. Okay, that's why that was there. Because we first made it without objects and then we turned it into an object. And you see remnants of that code that's commented out. Some things to fix. Maybe I'll draw a background that is gray so it actually looks like it's bouncing. All right. Cool. And now let's add on that bounce idea. So into here, bounce. Okay, what does it mean to bounce? Well, we're going to check if this dot right, which is going to be a direction variable that we need to add on, if that equals, oh gosh, JavaScript, what is your true? Does it look like this? No, in Python it's capital. No, it's lowercase. All right, if it is true, if you are moving right, then actually, hold on. No, this is move code, my bad. So if your x coordinate is greater than or equal to 200, then we change our direction. This dot right equals false. False. So in code, what this is saying is if you are moving, or if you hit, so in plain English, this line, if you hit the right wall, then your direction becomes left. Otherwise, else if this dot x is less than or equal to 0, so this means you hit the right wall. If you hit the left wall, then you move right. So then this dot right equals true. We already have an x variable. We don't yet have a right variable. So let's add that in. Right equals true. From here, your move will change if this dot right equals true. Then we add 1. Otherwise, so this means that this dot right equals false. Those two are the same thing. And then we go left, which is subtracting in our x direction. Alright, so with those changes, I wrote a bounce function. I wrote a move function. I should have broken it up more and tested it. I'll try to do that now. So it should still look the same. It still should be moving across the right wall. It shouldn't bounce just yet, so it should visually look the same as before, and it does. Great. Okay. And let's see, if we change this variable to being false, it should move left now, based on the code that we've written. Ooh, okay, great. It goes off the screen. Nice. And now we will add in the bounce part. So down here, it was moving, it was showing bob.bounce. Right, now it should bounce off the wall. And should it work off the left direction? Yes, it should. So currently it's starting in the center, goes to the left, and now we should see it move. Right, okay, cool. It bounced, and it bounced, great. It bounces off the center of ellipse, which may be visually bothersome to you, and you can adjust that if you want. For me, that looks okay. Now to add a paddle, you may want to start by not having it be an object just yet. Later, it will benefit you a lot by having a paddle object move up and down the screen, maybe just to get the effect. And to get this assignment started, we're just going to draw a rectangle that moves according to our arrow keys. Okay, so down here, let's draw that rectangle. Let's have it be very tall at x coordinate maybe 30, y coordinate 30. Length is short. Width is long. Well, not that long. 80. Let's see what happens. Cool. Seems like a reasonably sized paddle. Okay. Next reminder is now we need a variable. This is going to be px, which stands for the paddle's. Actually, x coordinate stays the same, right? Because it's moving up and down in this case. You may have Pong going left and right, in which case it's your y coordinate that's changing. So really, this should be py. That's going to start off at 30. And down here, you replace the y coordinate, py. Okay, so this rectangle is our paddle. Okay, so for those that just joined, I'm demoing for Computer Programming A, getting them started on their Pong with the paddle assignment. Any remaining time after I've gotten like the kind of a paddle working, then I'm going to focus on computer programming B's assignment. Okay. If key, oh gosh, this is where my P5 like escapes me. Is it up arrow like that? Oh, I remember all caps, but I might have the spelling wrong. If someone knows, do correct me. Oh wait, it should be minus. Okay, so if I press up, it should move up the screen, if I remember things correctly. Nope, remembered things wrong. So let me do a quick Google search. P5JS key code? Sure. Key code equals up arrow. Yep, okay. Key code equals up arrow. Let's go with that. Key code equals up arrow. Like that. Spell everything right. Okay. So now it should move slightly up the screen when I press the up arrow. Yep, there it goes. Okay, maybe key code's not exactly the thing I wanted, but for now it will do. Why do I say that? Because when I press the up key and I release it, it still keeps moving up, which is maybe something you don't want, right? Maybe you want it to move incrementally each time you press it, or you press and hold. We have those variety of key functions for us to play with, but for my demo, that's good enough. Key code equals down arrow. And then we add to our y coordinate. Okay. So, don't forget to press the screen, move up, move down, great. Okay, now the bouncing part gets a little bit more complicated. So, for this first bit, right, the paddle is going to move off the screen. I want to think about my bouncing so far as moving the wall up, okay? So we're just going to change where this ball bounces. It's going to bounce not comparing where the x coordinate is less than 0. It's going to be at x equals 30 now. So that's the first part. It's too much, right? Because even if the ball right now doesn't touch the paddle and bounces, then like let me show you what I mean, right? So for this bounce method, right, currently it changes when it hits the left wall, correct? Down here, right, which is not pure, like not, it's breaking the object orientedness of this, it's not really the object oriented, it's breaking like some, what's it called, encapsulation properties of object oriented programming, like, but that matters less for the computer programming A class. So now to get it to bounce, right, bounce a little bit earlier, you're going to check Bob's x coordinate, not Bobo, Bob, right? Like that, bob.x. If it is less than or equal to 30, which was the coordinate of your, where the paddle is, right, then you will change your direction. Bob.right equals true. Great, thank you, gentlemen. Okay, cool. So we have a couple fixes. Nice, thank you, appreciate that. So key is pressed and key code. Okay, so I think I'll make this change since that makes more sense to me right now. So this one will get us to like get that single tap, I think. Okay, let's see. I spell it right? Key like that? Or is it like this? Fascinating, because now when I do this, right, it doesn't move. So I'm pressing on the screen. These two things don't move right. Oh, darn it. So let's try key as pressed. Is capital I pressed, and then key, is it? Okay, you have to remind me. Key is pressed. That's a function, right? Like that. Anyways, okay. The people in the chat wanted to help out. Key is pressed is a function. Okay. Key is pressed, and then key, like that. Key code. Gosh, I forgot what I wrote. Up arrow, like that. Yeah. Nope, I'm out of luck. So, okay, you guys work on like refreshing this part. Getting me, yeah, that looks wrong. I forgot how key press works. I haven't used it in a while. So let's just leave it alone. Gosh, now I forgot what I originally wrote. Oh boy. Good morning. Okay, let's just leave it like that. No, it's fine. So yeah, ignore that. And so now if you notice, as you watch the ball, we've moved it up 30 or so pixels, right? Okay, so you notice it doesn't go very much past the, because the center of our ball is the one that's being detected, it kind of goes past it, but no, it doesn't go against the left wall. Maybe I can make it a bit more obvious. What's my radius on my circle? 100. Okay, so maybe we'll add like 40-ish. My code stopped working after putting py equals 30. Py equals 30, okay. If py up here is equal to 30, I used it for the rectangle down here. Okay, so pretend this movement code right here isn't there. Claire, do you have that much? Yeah, okay, cool. Now this is the funny part. Let's just try to get up working, which temporarily has this behavior. Okay, if key capital C code equals up arrow, when you press up, it should glide upwards. Right, only pressing the key once. You got that much? Because I know this is a confusing bit. Okay, yeah, when you run your program again, your paddle should be in the right spot, correct? When you just press up, it will move off the screen. That's okay for now, as long as it's moving. That's the main part. Because once we add in this down code, that's what allows us to like keep it onto the screen as we press the up and the right arrow. Okay, your ball stopped moving. Well, okay, so we're gonna, thank you. Is that the up arrow, Liam? You told me 87, and like, which one is that? I don't even know what key that is. Okay, that's W. Okay, looks like you're doing W and S. Let's keep it. Okay, so it's 38 for up and 40 for down. 38 for up. Actually, 38 for. 38 for. Yeah, 38 for up. And then 40 for down. Okay, so this is more of the behavior that we wanted. Alright, cool. So in the chat, you'll see there's other examples for it to work, right? So now when we press the key, it looks like this. Here's even a third way, right? Let me write just some comments when I share this code with people. Another way to get the ball, the paddle to move. Okay, and then here's a question from the chat. The ball stops moving when I add the rectangle into the draw function. Ball stops moving. And you already made a ball object, correct? Okay, link me your code, and then I'll put it as a part of my video. Because I don't think, just from talking without seeing it, I don't think I'll get it in a quick way. Okay, and I'm gonna record and paste this portion of the code. Yet another way. Great. Yet another way. So just to document it for those watching, here's 3 different ways to get like the behavior with your key pressing to work, and it's a good refresher since we haven't done this stuff in a while. Oh, I see. Right. Key code double equals arrow up. This was another way that was mentioned. This one down here. Key code equals arrow down. And all this gets wrapped into if key is pressed. Alright, so that's the 3rd way of getting it working. And we will test to see that it works. And all of them might be slightly different, and it could affect your gameplay. It could affect how you want your program to be. Oops. Maybe that's, wait, did everything just freeze on my end too? Let's try that once more. Yeah, I put this stuff in the wrong stuff. Alright, so this stuff seemed to break my code, so let's just leave this stuff in. So I'm getting that freezing motion with key is pressed. So I'm just gonna leave that there. And so let's take a look at this student's code where their ball also freezes. Maybe they'll have the same issue as me, maybe they won't. Let's do some debugging, as I'm not there in person to give you some hints. Okay. So from this, as it loads, we see that. Oh, and a note for computer programming A, if you're adding on to the same code pen, you may want to fork it when you turn in your assignments so that I see your part 2 and your part 3 changes so that they're separate. I forgot to mention that in my assignment prompt. No biggie if you've already, like, if it's too hard for you to recreate that, it's fine. Okay, so for this student's code, they were working on the PY, getting the paddle to show up. Right now it's not there, and so this is the more complicated bouncing ball. So it does the diamond kind of movement. Cool. Move, bounce, show, rectangle, PY. Okay, so one way to debug is we'll comment out stuff that isn't there yet. Okay, let's make the paddle go away. Alright, so there's the original animation, right? Ball bounces, great, great, great. Doop, boop. Okay. And so let's repeat those steps. Let's just try this with 30. We should see some kind of rectangle appear onto the screen, great. And what's wrong with PY? Where is PY defined? Notice right here, right? So this is the mistake. PY right now, when you define it up here, is inside the ball class. Okay, it's not what we want just yet, because PY is something that doesn't belong to the ball. Py stands for the paddle's y coordinate. So it should be way up here. For this student, their up and right variables right now live outside the ball class, but notice they use it in here. So that's one change. Since these variables are tied exclusively to the ball class, we should move these in here like x and y. And then this should become, this line of code should be this dot right equals true, this dot right equals false, right? This dot right equals true, this dot right equals false, so on and so forth. So there you go. Py being defined there, outside of the ball class, because it doesn't have to do with the ball. Py is paddle's y coordinate. And now once we place it back in, it should work. Okay. And now when we uncomment this stuff, it should be fine. You got it? Okay. So back to, yes? Jared, question? Okay. Cool. So here, we got the paddle to move, sort or another way. So this one kind of, I don't know why, I'm not going to spend the time to investigate it. Doesn't work yet. Okay, so we got the paddle to move up and down, great. And now let's investigate this part. So I was looking over the radius, right? Instead of being 30, maybe we'll make it 60. So it looks more like it's bouncing off the paddle, the edge of the ball, right? So that's a bit more obvious, right? That it is bouncing off there. But notice, right, this is the weird part. When there's no paddle there, it still bounces off like that invisible wall. Like animation-wise, this doesn't make sense, what I'm showing you right now. But when this occurs, that's okay. Okay, like that. All right? And that is when we have to narrow the boundaries of our y. This is the confusing part, because right now we're checking the ball's x coordinate, correct? Now we need to add on restrictions on the y coordinate. Instead of being that entire wall, like this, okay, it should be just where the paddle is. So if I move it like here, for example, right, it should be just the like upper third of the screen. And whenever I move, and that's the complicated part, like here to here, then that boundary changes. Okay. So if I had a whiteboard, I would show you. Maybe I can do so with lines instead to like track it. So temporarily, let me add in some extra lines to make that a bit more clear. And if you understand what's going on, like what I'm trying to say with the x coordinate, then that's great. This one will go from x. Oh no, it's not part of the ellipse. Okay, so I'm going to add in some lines to show the binding, what's it called, like limiting the movement, the bounding on the y coordinate. Okay, so it's going to start at the upper part and then go all the way to the edge, but maintaining that same y coordinate. Still, and the x coordinate is going to be way at the edge. Okay, so this is going to be temporarily there, right? And when I move, notice like that's the range that it's also moving at, right? And then second line at the bottom, when I add on 80, that becomes 110. like that. Alright, so with these extra lines that I've drawn in, oops, did I mess it up? X coordinates were way over too much. It's still 30. But this Y, that X coordinate's good. Oh, like that. That's what I wanted to do. Okay, now I get the line at the bottom. Yes, okay. So you see those two lines I added onto my paddle, right? Like that's the area that we want to track now, right? If you're in Algebra 2, this is like linear programming. We're checking in the range. It's not the entire right side of this paddle, it's only this rectangle that I've demonstrated with the lines, right? That's like when it's okay to bounce. And if you look at my assignment prompt, that's what I kind of drew for the in that whiteboard diagram. So tracking it, that is the harder part. That's when we have to use those ands and ors. So not only does your x-coordinate have to be less than 60, then you change right. You must also, right, be between, and this is where the logic gets kind of complicated. Bob's y, okay, let's spell out in English. Bob.y has to be between I'm trying to look at my paddle's dimensions again. So it has to be between py and then py plus 80, because that's how long your paddle is going up and down. Where is it? It has to be between py and py plus 80. Okay. English, that's what it means. And as we make that comparison, okay, because y grows positively downwards, right, you have to be greater than py. And bob.y has to be less than p-80, right? So that's this from the bottom line of the rectangle going upwards. Okay. And that's, I think, the most complicated line of logic right there. So only then do you bounce, right? Gosh. Okay, so notice right now, because the paddle's out of the way, it goes to that far wall. Do you see that? And then as we move it back into here, it's clear, it's within range. Shoot, it didn't work. I got my logic wrong. Once the x's coordinate is less than 60, Bob's y coordinate, py, and bob.y is less than py plus 80. Did I type it wrong? Someone check my math. Is that how do I get it between? Bob.y is greater than p.y. P.y is upper left-hand corner. Bob.y has to be less than py plus 80. One more time. Oh, you know what? I know the mistake. So right now, we don't have a bob.y. We scroll up to our bob code, right? Our ball code. It doesn't have a y coordinate. So let's add that in. So save and run. Now that the y coordinate exists, there we go. Okay, so now clearly the paddle should be bouncing, yes? That makes sense. And now when I go away, it should go past my paddle. And it does. Cool. I apologize, computer programming V. That took like the whole class to do. I'll make a little video for you going over parts of the assignment, making a statue, for example, later today. How about that? And then you can watch it. Yeah, more content. Sorry. It's hard teaching 2 classes. I won't have to do so next year. But there you go, computer programming A. There's your logic. I recommend that you write it out and understand what's going on, because when it goes diagonally, like 2-dimensionally bouncing, then it becomes way harder. Yeah, I did the simpler case to kind of describe the logic. It's hard not being in person to explain it, but there you go. And I'll give you this code and upload this video so you can follow along. Okay, that's the key idea behind the paddle. And notice right now, like, we didn't even make the paddle object. We got the animation to behave the way that we want it to, correct? We still got to turn this paddle into a paddle object to do your brick breaker assignment. All right? So that's all for today. All of this is for computer programming A. And don't forget to do your reflections. I'll release you now. Yeah. Right, and I'll upload this video along with this code to YouTube.